line, batch WDG 2024-001 have arrived. Please begin unloading.
Against the BOM. Everything looks good.
High uniformity confirmed. We can approve the panels are placed on hydraulic lift tables to prevent warping. QC then uses
A center speaker not only needs to look good on the outside, but must also control standing wave.
The design is locked. Ensure the machining tolerances for the driver holes are precise. Looks good. Approved.
Transferring the file to the CNC controller now.
prints barcode labels for each enclosure detail. Staff attach these labels containing batch codes and production.
Measurements are good. It checks out.
All right, team, the first production batch.
This panel shows a minor deviation, yet it needs rework before gluing. Understood.
The remaining sets meet the standards, though.
Since this is a high-end center speaker, the visual aspect must meet premium furniture standards, not just mechanical standards.
Remember the rule. All parts must match the exact kit code. No.
The body more rigid, limiting enclosure wall vibrations when the speaker operates at high volumes, and dividing large panel surface.
Top panel is lowered. The multi-point clamping system is then
Gauge is holding steady and the timing sequence is correct.
Looks good, team leader. We are maintaining the shape perfectly.
Right here on this edge, we need to clean that streak before it hardens.
the curing stage cannot be skipped, as bond strength depends not only on glue quantity and pressure, but also on Each enclosure isn't just physically precise, it must be treated as a miniature acoustic chamber. One operator directs compressed air to blow dust out, while the other immediately vacuums. Damping material isn't just slapped on everywhere. It must be placed exactly where vibrations are strongest according to the design.
Workers insert the damping pieces into the enclosure, pressing them down firmly with rubber rollers to eliminate air bubbles.
Right here, the sensor peaked when you tap that center brace.
Acoustic absorption doesn't mean stuffing as much in as possible. Every position, thickness, and density is calculated to control.
Done with the adhesive.
All right, pressing the panel firmly now, checking the clearance with the gauge. Looks good.
The simulation highlights why this staggering is critical for standing wave disruption.
We must ensure they don't block the airflow port. Reinforcement plates are attached to the back panel for even force distribution. The process engineer then uses a template to verify clearance from internal components. Borescope camera allows us to inspect the inner enclosure, checking the acoustic foam and damping layers. Here is the completed documentation. Quality control checked and approved. Resonance. The tweeter stage requires extreme cleanliness, precision, and perfect concentricity.
If the magnetic gap is uneven, the voice coil will easily rub during oscillation, causing distortion or slight hissing. Approved tweeters are grouped by the closeness of their measured parameters, ensuring maximum uniformity for the production batch.
Compared to the tweeter, the mid/woofer requires a larger excursion and stronger mechanical force. This means every component from the
Mid/woofers oscillate powerfully. If the gap is misaligned, coil rubbing errors will be much more prominent and easily.
Winding machines wrap conductive wire at high speeds. Once complete, the coils are measured, reduce resistance.
The spider is joined to the voice coil using adhesive and aligned perfectly. A template ring is inserted to hold the exact geometry while the
cancellals. A perfectly even layer of glue is applied before using a specialized press ring to hold the surround tight. Sections A good driver isn't just assembled correctly. It needs time for all bonds to reach mechanical.
In high-end speakers, the crossover isn't just a simple electrical circuit. It's the coordinating brain for the entire frequency spectrum.
Capacitance value confirmed, batch code matches, approved. Winding layers look off on this inductor, core solidity compromised, move
your layout. The component layout isn't just for easy assembly. The distance between inductors, orientation, and mechanical stability must be
The physical frame of the crossover is now clearly visible.
Threads checked and contact surface smooth. Test fit confirmed.
Applying final torque now. Connection solid.
All connections secured on the board.
Good.
The routing looks neat, no interference with the absorption material. The lengths are perfect.
Each complete electrical kit gets a batch code, shift code, and pairing ID tag. The kits are then sorted into separate trays. From this moment, the crossover is no longer a collection of loose components, but a true acoustic.
Point on. All actions must be clean, precise, and gentle, as even a tiny scratch.
Using ultrafine filler and soft putty knives, we fill the micro gaps. A template gauge ensures the joints are level for a
The color depth is perfect. It meets all specifications on the checklist.
Flawless application. Final approval granted.
The final coat determines aesthetic durability, surface hardness,
Screws are torqued correctly in the cross pattern. It's solid. Confirmed.
I'm verifying the gasket seal through the inspection port now.
We snap the wires into the anchor points, keeping them neat to prevent rattling. A quick QC check confirms correct polarity using...
Polarity checked. Wires are secure. Seating the gasket now. I'll tighten these symmetrically. Looks perfectly.
frequency sweep is clean, crossover is dialed in.
Confirmed, no.
They're all signed off and ready for acoustic testing.
Good. We'll take it from here.
Temperature on Unit 42 is stable.
Confirmed. No secondary noise detected on this row.
Are repeated. The technician confirms the speaker has settled into the desired performance zone after burn-in. Vocal clarity is excellent, especially in the mid-range. The timbre is completely natural, and the imaging is
Here are the documents for the shipment.
confirmed. Batch 202707A is ready for transit.
There. Seals. Looks good. Signing now.